All right, welcome to what's probably the first terminal challenge. This is the video for Kringle Kiosk, which sits near the Shinny elf. And yeah, let's just jump right in. So head over to the challenge here. So this kiosk is right here. This is basically as you get off the gondola. And if you complete this challenge, you get some hints towards the second objective, which is the S3 bucket one. So if you initially click on Shinny up a tree, you will receive the following hint, one and only, and that is command injection here. So it says there's probably some kind of command injection vulnerability in the menu terminal. Then if you open this link, it takes you to the OWASP page for command injection. OWASP is the Open Web Application Security Project, I believe it stands for. And they are an organization that attempts to train and make people aware of common web vulnerabilities and mitigations. And so this page we're talking about, yeah, a very common problem, command or code injection. But I guess specifically here, command injection. And this this is an issue with regular terminal applications, desktop applications, and certainly web applications too. One of the most or I guess to start off with the definition of it is in my eyes it is exploiting a program to essentially execute more than intended, and actually executing commands on the system that's running the program, arbitrary commands that the application never intended to be run. An example that I see a lot with web applications is the classic, you have a web application that has some sort of a ping utility for like troubleshooting connectivity. And so it basically is a form that says, hey, put in any IP address and I'll ping it for you. And so the user would input some sort of IP address like 8.8.8.8, and you would click ping, and on the back end, the application would take that user input and it would actually run the ping command on like the Linux or Unix host, applying that user input as a parameter to the ping command. Now, where the command injection would come in there is you could easily, if the user input was not sanitized whatsoever, you could just piggyback on another command to that ping command. So it would ideally be running ping space user input, so ping space 8.8.8.8, and that would be it. But if they're not sanitizing user input, your input could be 8.8.8.8, and or colon space another command. So my input, if I wanted to run cat etc password, would be 8.8.8.8 colon cat etc password, and I would hit run ping command or run ping in the web application, and the application would take all my user input and it would apply it to the ping command, and it would subsequently execute my injected command. So that's just one simple example that I see a lot. Damn Vulnerable Web App has a lot of different training resources talk about that type of web application command injection. This one's a little bit different. This one we're working with a terminal application, same concept though. So if we go to launch this now, right here is the terminal. If I can click on it here, there we go. Okay, so it says book around, try running bash. Please try to come discover, need our devs, help recover. Okay, so really the important details here are escape the menu by launching bin/bash. So it says press enter to continue. Now we get into the actual application. Looks like it's just some sort of a basic menu app where it's saying, hey, input anywhere 1 to 5, and it'll spit some output for these. So what I like to do when I'm trying to analyze these command injection or analyze for command injection is start using the application as a regular user as it was intended, and just look at the output and just take notes, take mental notes of how the program responds to my regular user input. After that, start to get a little bit weird with it, and you're going to be inputting, like for example, SQL injection. If you're trying to SQL inject, you might start with SQL comments and trying to get SQL to spit an error, things like that. So, but here with command injection, we're going to want to try to the same thing with ping. We're going to want to try piggybacking different commands using colon, using and stuff like that, if we're given the opportunity to do so, and hopefully that'll allow us to launch bin bash. But let's start as a regular user. So we've got one. This spits out some sort of a ASCII map of the Santa's castle here. If we hit enter, it returns us back to the main menu. Okay, so that, not much, just printing some text out. 2, code of conduct, same thing, just spitting out text. 3, directory, same thing, spitting out text. Now, one thing to keep in mind is potentially in a future challenge, this data might be useful. This might be a hint in of itself. I don't know yet. We'll find out. But just keep in mind that anything can act as a hint in these types of challenges. So, but for the purpose of launching bin bash, this doesn't really help. Okay, so we gotta hit enter to continue, and then number 4. Okay, this is a little bit different. So it's asking us to enter our name. It says avoid special characters, may cause weird errors. All right, so let's just do Daniel, see what we get. Okay, cool, just some ASCII art with my user input Daniel. So that's a very interesting command. Number 5, exit, and just kills our connection. Okay, so we don't care about number 5. So we've gone through, we've applied our regular user input. Now it's time to start stepping up the type of input we're giving it. So let's just try like 1 colon ls. Does that give us anything? It doesn't look like it. It's just printing it out again. What if we do a number that's not between 1 and 5? So 0, error. Nothing, error. Okay. Okay, and then it returns. So can I do 1 again? Yeah, I can. Okay, what about 6? Error. Okay. What about like a double-digit number? Okay, 20. 10 gives the map. What about 20? That gives the code of conduct. So it looks like the program's only taking that first digit from user input and ignoring pretty much everything else. And as we saw, if it's not a number between 1 and 5, it'll spit that error out. Okay. So now the next thing that really stood out was going back to number 4 here. Let's try the same thing with entering our name. So let's do Daniel. Let's try an ls like we were before. So let's see if this will take our user input. And we saw it was spitting out ASCII art. So maybe with our user input, we can terminate that with a colon and have the shell also execute ls. Okay, so minor detail here, but very important. We can see welcome.sh. We did not see this before. So this looks like a directory listing for whatever directory this program is running in. So this is awesome. So now let's try, oops. Let's try, who am I? Okay, Shinny. Awesome. So we've discovered the command injection. We know this is applications running as Shinny, who is the elf, so all that makes sense. Welcome.sh, probably something to do with this program. We could even try catting that out if we wanted to. So cat welcome.sh. Okay. So this actually looks to be the program that's running right now. So now we have access to the source code, which is always ideal for identifying vulnerabilities and stuff. Yeah, so the surprise is weird. Op plant. Wonder what that does. Cat/op/plant. But yeah, it's getting our choices here. We can see that's where it asks for second choice, or our second input option, our name for that deer ASCII art. Yeah, okay, so it's using cow say. Oh, so here is the, I guess, vulnerability right here. So it is taking name as user input. That's what we're providing. When I say Daniel, it goes there. And if I do colon, or I do and I input another command for bash, such as ls, such as who am I, it's going to execute that. So that's the vulnerability there. Is it's trusting that user input too much. And it's just saying, hey, just directly execute whatever the user gives me. So with that, let's just try launching bin bash as asked. Boom. What just happened? Okay, well, almost managed it. My browser did not like that for some reason. Anyway, that was weird. So anyway, we managed to launch bin bash. If you hadn't solved the challenge before, you would have gotten a pop-up in the lower corner saying, hey, congrats, here's some more, and it would have given you hints for the next challenge. So this is how you solve this. One thing I do want to do is, we saw on this source, was it plant.txt? Yeah. Hi, my name is Jason the Plant, EJM96. I don't know what that means or if it'll be useful, but let's keep that in mind. At any rate, this is how you solve that challenge. Hopefully it made sense with the command injection. Key takeaway here is don't trust that user input. Don't execute, commands using a shell from user input ever. Ever, never do that. And that's the challenge. So pretty straightforward from a command injection perspective. We didn't have to tweak or sneak in a lot of stuff. It was basically probably the most simple type of command injection you can get, where it's trusting that user input and it's just executing anything you give it. So let me know if you have any questions in the comments. Be happy to provide further explanation if something did not make sense. But otherwise, now we've got some more hints to complete the S3 bucket challenge, and that's exactly what we'll do in the next video. So thanks a lot for checking this video out. See you in the next one.